Ever pondered why the Earth's landscape is so varied and dynamic? Why are there towering mountains, expansive oceans, and deep trenches? Underneath these fascinating phenomena lie the fundamental geological concepts of plate tectonics and continental drift. Imagine the Earth's outer shell, the lithosphere, as a giant jigsaw puzzle. This puzzle is composed of several large and small pieces or plates, which float on the semi-fluid layer beneath them, known as the asthenosphere. Now, these plates don't just sit idly. They're constantly on the move, driven by the heat generated from the Earth's core and mantle. This heat creates convection currents that push and pull the plates in various directions. The interaction between these plates results in a wide array of geological phenomena, from earthquakes and volcanic eruptions to the formation of mountains and ocean basins. Now think back to a time when all the continents were part of a single massive landmass. This was the idea proposed by Alfred Wegener in the early 20th century, a concept known as continental drift. Wegener noticed that the continents seemed to fit together like pieces of a puzzle. He hypothesized that these land masses were once joined together in a supercontinent he named Pangaea, which began to fragment around 200 million years ago. The drifting apart of these continents is an ongoing process. They move in sync with the shifting tectonic plates beneath them. As these plates diverge, converge, or slide past each other, they shape the face of the Earth, carving out oceans, raising mountains, and forming deep ocean trenches. Consider the phenomenon of divergent boundaries, where two tectonic plates drift apart. At these boundaries, magma from the mantle rises to the surface, forming new oceanic crust and triggering volcanic activity. This is clearly visible along mid-ocean ridges, such as the Mid-Atlantic Ridge, where new crust is continuously being formed. On the other hand, convergent boundaries occur when two plates collide. This can lead to subduction, where the denser oceanic plate is forced beneath the lighter continental plate, or it can result in continental collision. In subduction zones, deep ocean trenches and volcanic arcs are formed, while continental collisions give rise to immense mountain ranges. Lastly, there are transform boundaries, where two plates slide past each other. This lateral movement can cause earthquakes as pressure builds up and is released along fault lines. Plate tectonics and continental drift are not just theories. They are the keys to understanding the Earth's dynamic nature. They explain why our planet has such a diverse landscape, and they help us predict where geological hazards might occur. They also allow us to trace the evolution of continents over millions of years. As scientists continue to explore and research, we're gaining a deeper understanding of the dynamic planet we inhabit. And who knows what fascinating discoveries await us in the future.